Okay, so welcome to problem 1 of our number sense series. This is the second number sense series, so if you want to take a look at the first one, I'll have that linked in the description down below. But this is number sense number 2. So first, what is number sense? Number sense is, kind of testing your sense with numbers. So it's going to ask you things like, find this digit, or fill in these blanks, or is blah 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 number divisible by blah. So there's a lot of division in here. Because of that, before we do any problems, I would like to go over some divisibility tricks that we can work on. So I have the video on divisibility rules in the description down below. Those are the basic ones. So first watch that. Okay, so you come back, you kind of know some of the basic ones. Now I'm going to go over some special ones, and that's 7, 11, and 13 first. And then I'll do 99. Okay, so 7. If we want to see if a number is divisible by 7 or 13, okay, so yellow is for 7 and 13. You say we were trying to get the random number 6, 7, 4, 5. Okay, and we were trying to see if this number was divisible by 7. What we would do is take the final 3 digits of that number and split it into 2 sections. Now we have the number 67 on one side and 245 on the other side. Right? And we take the bigger number and we subtract it. So in this case, 245 is bigger, so we subtract 67 from 245, right? And then we get 178. Now we have this difference right here, and we just see if 178 is divisible by 7 or 13. And this obviously is not divisible by 7 or 13 because this is even. So this is not divisible by 7 or 13. Now we're going to take a look at 11. This way also works for 11. It actually also works for 11. It's just that 11 is a very, very special number, and it's a number that you especially want to really think of when you're doing number sense for a problem, say on a test, because 11 is the number that the problems are mostly going to be challenging you with. So how can you find out 11? Well, I'm going to use pink for this. So we're still trying to find if 6, 7, 2, 4, 5 is divisible by 11. Remember, this way still works, but this is a trick just for 11. So if we label the ones place 1, and we label the tens place 2, and we label the hundreds place 3 and 4 and so on, right? You see we have 1, 2, 3, 4, 5. So we're kind of labeling each of these place values. Now what you're going to do is take all of the odd numbered digits. So in this case, that would be 6, 2, and 5, right? Because they're in the odd place values, and we're going to add them. 6 plus 7 plus 5, okay? Then we're going to subtract the digits in the even place values from that. So we add the 7 Okay, sorry, this isn't supposed to be 7. This is supposed to be 2, sorry. Now we add the 7 and the 4 because they are the digits that are in the even place values, okay? Then we just see this difference here. 6 plus 2 plus 5 equals 13. And we minus 7 plus 4, which is 11, and that gives us 10. So what if the odd numbers, this sum right here isn't big enough to subtract the even place values down? Well, you would continue adding another 11 to this sum until it is large enough. So that's how it works. And remember, this only works if you subtract the even from the odd. So repeat after me. This only works if you subtract the even from the odd. Okay, and quickly review some of the easier ones. We know that 222, and so we know that 2, 4, 25, 8, 125, 50, all of those numbers, you only have to look at the last two. You only have to look at the last 2 digits or the last 3 digits. So I'm not going to go over that. And say if you have a number that's, maybe 72, you can just split that up into 8 and 9, and you probably know the divisibility rules of 8 and 9, right? And 9 is also in 9 and 3 are very special because you just have to add up their digits, find their digit sum, and then you see if that digit sum is divisible by 3 or 9. So that's when it comes to digit sums. I'm going to teach you a very special way that only works with 99. Now, when you first look at 99, you might be like, well, isn't that 9 times 11? Don't we know 9 and 11? Why don't we just split that up? Well, 99 is a very special number, just like 11, and on tests, it's very likely that there's going to be a question on 99. So that's why we have a special way just to figure 99 out. So here's how it works. First, okay, we're still going to see if 6, 7, 2, 4, 5 is divisible by 99. Okay. What we're going to do is split from the very last place value, split up these digits in groups of 2 that are next to each other. So now I have 45, 72, and if you don't have any number over here, just leave it alone, and it's okay if you don't have a number to pair it up with. You can think of it as there's a 0 right here. Anyway, we pair these up, and then we have the numbers 6, 72, and 45. Now, we're going to add 6, 72, and 45. So after we add, 6 plus 2 plus 5 equals 13. Carry that. And then we get 123. Now the sum, if the sum is a multiple of if this sum right here is a multiple of 99, then it means that this number is a multiple of 99. But it's very obvious that 123 is not a multiple of 99 and cannot be divisible by 99, which means that 6, 7, 2, 4, 5 is also not divisible by 99. So again, another digit sum divisibility rule, but this one's a bit special. Remember to, starting from the very last one, to really clearly group these up into partners of 2, and then just add these numbers up in the end. Okay, so this is very important. I hope you can, if you can, maybe even write it down to think about that. Now we will be moving on to our problem. So this is problem 1. Two four-digit numbers, A275 and 275B are multiplied. If their product is divisible by 72, find A and B. We just went over how 72 can be split up into 8 and 9, right? So we know, okay, so there should be a line up here. So we know that the two numbers, A275 times 275B is divisible by 72, and 72 can be split into 8 and 9. So we just need to make sure that one of these is a multiple of 8 and one of these is a multiple of 9, or maybe one is just already a multiple of 72 themselves. So this has, so right here, oops. So let's first think about which one can be a multiple of 8. 8 is an even number, which means it has a special need. So it's any single multiple of 8 has to be even. But it's very clear that this first number right here, A275, cannot be a multiple of 8 because it is odd and ending in 5, which means that this second number right here has to be a multiple of 8. So if this number has to be a multiple of 8, then A275 should be a multiple of 9. Okay, and 9 is pretty easy because 9 is just adding up digits. So we know that so let's see what is a digit sum already. So we have 2 plus 7 plus 5, and that equals 14. Well, that already went past our first multiple of 9, which is, well, 9 itself. So the next multiple would be 18, making A equals 4, because we need another 4 in order to get 14 to 18. Okay, so A equals 4. And what about B? Well, we know that if you're trying to find a multiple of 8, you look at the last 3 digits, right? And making B 2. So B equals 2, right? Because we need to make sure that the last 2 digits is a multiple of 8. So the whole number is a multiple of 8. Right, so our final answer is A equals 4 and B equals 2.